Good evening. It's great to see you here. I'm Carolyn Grossman, the Executive Director of the Rustandy Center for Social Sector Innovation at Chicago Booth, where I'm also on faculty. And I'm delighted to welcome you to tonight's panel discussion on AI, the economy, and public policy. First, thank you to our hosts, the Becker-Friedman Institute for Economics. BFI serves as a hub for cutting-edge economics research across the university to uncover new ways of thinking about economics and to bring those insights to decision makers around the world through accessible and actionable formats. For those walking in, there are a few seats at the front. You can make your way up if you like. I'm always glad when my home base and Booth's social impact hub, the Rustandy Center, has an opportunity to collaborate with BFI. At the Rustandy Center, we're focused on advancing research, training, and programs that use the tools of business to address societal challenges, and conversations like tonight are an important part of that. It seems like wherever you turn, AI comes up. I know we're in the midst of incubating new ventures and social ventures and the Social New Venture Challenge at Booth right now, and so many of those incorporate AI, which is fantastic. The technology is advancing rapidly, and the questions around its economic impact and policy implications are still taking shape, which is what makes tonight so important. So format-wise, tonight's program will begin with brief presentations from each of our four panelists. Then I'll moderate Q&A, and we'll leave time at the end for Q&A. So as you have questions, especially during the initial presentations, please jot them down, and I'll make time to get to as many of them as possible. Now, on to introducing our speakers. Anders Humlum is Assistant Professor of Economics and Fujimori Mo Faculty Scholar at Chicago Booth. A labor economist, Anders studies technologies, past and present, and how they affect workers and firms by analyzing the rise of robotics, the second industrial revolution, and the role of reskilling in helping vulnerable workers adapt. Anders will be presenting a new paper tonight that was released earlier today. So if that's not cutting edge, I don't know what is. Samir Mayekar, my colleague, we work very closely together between the Polsky Center and the Rustandy Center. Samir is Associate Vice President and Managing Director of the Polsky Center for Entrepreneurship and Innovation and a faculty member at Chicago Booth. He leads innovation, technology commercialization, and entrepreneurship initiatives across UChicago. Samir has held leadership roles in local and federal government, leading Invest Southwest for the city of Chicago, and in industry as co-founder and CEO of Nanograph Corporation. Sanjog Misra is Charles H. Kelstadt Distinguished Service Professor of Marketing and Faculty Director for Booth Center for Applied AI. Sanjog investigates how firms use data to make smarter decisions around pricing, targeting, and marketing. And finally, Alex Tamkin is a research scientist at Anthropic, so joining us from the field, and is the lead author of the new Anthropic Economic Index, which uses real-world data, usage data, to track AI's impact on jobs, tasks, and more around the economy. What a great group. Anders, would you get us started?
Thanks so much, everyone, for coming. Really excited to have this conversation with all of you. So as Carolyn said, this is really hot off the press. So I'm really excited to share this. Okay, so this is a part of a larger research project I've been running, trying to understand the labor market implications of AI, and in particular, these chatbots that are now everywhere. Okay, so this paper in particular was really motivated by two facts. Okay, so the first fact, which is now widely established, is that the adoption of chatbots have been probably the fastest ever to diffuse. So it's really astonishing how fast, for example, ChatGPT have diffused in workplaces, on campuses. So it's really a big deal. And the second fact is that there is now several well-crafted experiments, so randomized, controlled experiments showing really astonishing productivity gains from these tools, like often more than 20%. So it seems that there is a great potential in these tools. What we would like to do, and what we were setting out to do in this project, was to understand, well, how do these potential gains then manifest itself in the real economy, in the real labor market, where workers are using them. Okay. Okay, so to do that, we teamed up with Statistics Denmark, where we could run really large-scale surveys. So we ended up, so the last survey round that ended here in winter, we have a sample of 25,000 workers from 7,000 workplaces across 11 exposed occupations. So we can really get a very in-depth and nuanced understanding of how these tools are impacting the economy. Okay, so I think so my idea was just to show you some cool plots to set the stage for further discussion, just to get us started. Okay, so the first questions I had was, we've seen this very rapid take up among workers, but are firms actually also actively investing in this? And what this plot shows is the share of workers across these 11 occupations, where in the red here, firms are actively encouraging workers to use the tools. And what the graph shows is that now we're really in a phase where most firms are quite aggressive in actively encouraging workers to use AI chatbots at work. More than around half of workers are actively encouraged, more are allowed to use it. Okay. So do these encouragements, are they just words? No, they're actually also firms. They're putting their money where their mouth is. So around 40% of workplaces have now their own AI chatbot. That's usually some version of GPT, but then also trained on in-house data. Around a quarter to a third of workers have received training in this. So I think this just shows you how big a deal this is. All of this has basically happened within the last year. I don't think we've seen a tool or technology with such a rapid take-up and transformation just within a single year ever. Okay, so do these encouragements matter? They matter a great deal. So here, for example, we show the take-up rate, so workers who have ever used, who are using it monthly, weekly, daily. And the blue dots shows what is the share of workers who are using it even if they're not encouraged to use it, okay? And this really shows in the blue kind of the bottom-up adoption that has happened, that even if they're not encouraged, still more than 40% of workers have used these tools at work. But then what the red dot shows is that firms and employers can really move the needle. If they actively encourage workers to use it, for example, also providing training, we can essentially double their adoption rates. Okay. Importantly, these employer policies also really matter for who are using the tools. So something that came out of our early research on this is that there's a huge gender gap in the adoption of ChatGPT. Women are much less likely to use these tools compared to male workers within the same occupations handling the same job task of similar age. Okay, so we replicated that. That continues to hold here in. So, for example, now, if you in the baseline without encouragement, if you take two workers in the same occupation, same age, they're earning the same amount, they're similarly wealthy, similarly experienced, the woman is still 12 percentage points less likely to use AI. Okay, but what the red curve or the red dot shows is that employers can really change this picture. By explicitly encouraging workers to use these tools, we can essentially close this gender gap in half. So again, I think it really shows that employers and firms have an important role to play in this. Now, it's not these encouragements matter not only for who's using it, but also the benefits that these users are getting out of it. So both time savings, the quality of output, how creative workers feel when they're using it really depends on whether the whole workplace is reorganized around it. So I think this shows that there's a great potential for transformation here, especially when firms are actually on board and encouraging workers to use it. And we see this, I think the clearest sign of transformation is that around 10 to 15% of workers have new job tasks, something they didn't do before, that they're now is part of their daily work due to AI chatbots. So just a funny anecdote, like one of our of our occupations are teachers. A lot of teachers say that now they have to detect whether the students are cheating on their exams with AI. But in general, there's a lot of work that now goes into overseeing how the AI chatbots are working and generating output. Okay. So the key, and that now we're coming to kind of the title of the paper, is that we wanted to understand, well, does this matter for you? Now, I'm a labor economist. I care about what people earn in the labor market, where they're able to find a job, okay? So what the Danish setting allowed us was to take these survey responses and then link it to administrative data on workers' earnings and employment hours, covering the whole economy. Okay? And here what I'm plotting is the earnings of adopters relative to non-adopters before and after the arrival of ChatGPT, which is by far the most dominant AI chatbot. Okay? And then we can now use the registered data, the admin data, to extend this curve. And this is kind of the punchline of the paper, is that in terms of economic outcomes, these chatbots have not been a game changer, thus far at least, okay? You see really no break in trend in terms of earnings, in terms of employment hours. Workers have started using this, but we don't see this really making a big difference in terms of the labor market outcomes. Okay, so you might say, are there really no one whose labor market outcome have benefited from this? The richness of the Danish data allows us to make many cuts, and really the conclusion is, right now, we should not fear workers losing their jobs due to AI chatbots. We should not really expect workers to move ahead either in terms of their earnings. Okay, so why is this the case? We saw these experiments that I motivated with, showing these huge potential. And I think there are two key reasons why the actual economic impacts are much more limited. The first thing is that the realized productivity gains, so the actual time savings in real life workplaces, are much more modest, around 3%, not these 20% or more that the experiments are showing. And the second thing is that one thing is time savings, another thing is how that is then passed through to earnings. And there's a quite weak link right now between the productivity gains that workers are enjoying and their earnings effects. Okay, so I'm just going to wrap up here. I think this is still early days. It's only been 2 years since the arrival of ChatGPT, but I think still it's useful to kind of take stock and just realize that any story about big transformation has to contend with the fact that right now we don't see a big change in the labor market. Okay, this could happen, and I think our paper, and I really encourage you to go read it, is that I think the key for the big transformations are firms. It was really the workers, this bottom-up adoption, that drove the very rapid adoption of these tools. But I think it's going to be the firms, in terms of reorganizing workflows around the tools, that are really going to drive the economic transformation. Okay, so I'm going to stop there. Thank you.
A slightly different take. So I'm going to talk broadly about a bunch of different projects that I've worked on, but I'll showcase one and give you an idea of different things you could do with this framework. So here's some math. So what I want to talk about is this idea of using AI to generate policies, right? And you can think of a policy as you put stuff in about a person, let's say, and some stuff comes out, but we want that to be the optimal thing to do. And I'll explain what I mean by this. So in a business context, you might put some characteristics of a consumer in, and out comes a price or a discount. In a policy context or a public policy context, it might be that you put some information about a particular citizen in, and out comes a recommendation of whether or not a loan or a parking ticket should be forgiven, right? So you can think of these as individual policies, and we're at a point in time where we can scale these policies down to the individual. Part of building these AI tools is to be able to figure out how people think, right, or how people would react. And communication in general is kind of this key ingredient. What we want to do is to get people to fill out forms like this. So what's this form? This is a particular context. This was a project with the state of California and their administration of the food stamps program, also known as SNAP. And the idea was, well, if you're poor, you can qualify for food stamps. It takes a little bit of effort to get there. It's arduous, it's expensive both for the state and for the citizen to kind of get this going. 6 months after you've qualified, you have to fill out this 2-page form that says, I'm still poor, essentially. If you don't fill out this form, you lose all your benefits and you start the process again, right? So it's an incredibly expensive thing. So what do we want? We just want to be able to tell the citizen, fill out the damn form. Right now, these are people who are struggling. 33% of them are on the streets, so filling out a form is not, top of mind. But they all have access to some form of communication, either through phones or through email. So the trick would be, let's send them a message, a nudge, if you will, and get them to take this action of filling out the form. And in order to kind of build out this nudge, you have to anticipate how the citizen would actually react to the message that you're sending them, right? Now, why do we have one nudge? Why can't we have one nudge for every person? We could, but that would mean that we have to learn and build models for each person. And that's what AI allows you to do in some sense. And I'm not talking about just using language models. I'm thinking about building your own small language models that will allow you to generate personalized nudges given a set of characteristics of a given person. I'm not going to bore you with all the details, but we did this. We basically collected data, ran some experiments, built out a deep learning model which could generate personalized messages that tailored towards how you would like to hear. So some people are motivated by loss aversion. So like if you don't do this, you're going to lose your benefits. Some people might be motivated by urgency. You have to do this by this particular date. We learned what characteristics kind of matter and tailor the language accordingly. The effect in California in one campaign, $14 million more went to poor people, right? Directly because of this intervention. I was invited to kind of present this at the USDA, scaled the number up. If you implemented this across the US, the incremental, so this is above and beyond a uniform nudge. So if everybody got a nudge, this is the incremental effect would be about $4.5 billion. No takers, but that's a whole other story. Now, I'll kind of conclude with just giving you an idea of why this framework is useful in a huge number of policy contexts. You could do this with firms. We have actually done this with a firm in terms of tailoring prices. But in the last 5 or 6 years, I've started porting these technologies to the social sector. So we're working with a large city to the west of here, which I'm not allowed to name, where we are building a forgiveness AI, right? The idea is to learn who are the people who are not paying their bills because they cannot pay their bills versus who are not paying their bills because they just won't pay their bills, right? And so by offering kind of randomized discounts at different levels, we're trying to learn what this pattern of repayment is, use that to build an AI that then tailors the discount and the way that discount is presented and the language that's used to present this discount to citizens to get them to pay their bills, essentially. You can think of this as a general thing that you can think about parking ticket forgiveness, for example. There are people who can afford to pay their parking tickets, just don't, and then there are people who just cannot. And can we use AI to kind of learn what those hidden preferences are and then tailor the policy based on that? So that's one application. Outreach, advertising, messaging, all of that falls into this class. So I've taken a bunch of this and now applying this in India as well. there, it's amazing, right? You've got massive amounts of scale. So in one particular example, we are building a personalized video for disadvantaged kids to encourage them to learn, right? So you can think of, there's nothing special about generating text messages, which you could do, but you could also generate video and audio using the same ideas. Learn what different components of the video kind of are useful in getting somebody to engage with that video. And then rather than think of generating one video, which is the current generative kind of framework, you generate optimized videos, which are like a combination of many different components, so that now you have a personalized video to get you to engage in a learning task. That could be like some kids are, they like exciting stuff, right? So that it starts with that. Or some kids like something that's a lot more serious and a lot more technical. And so by just matching up this in an optimized way, by learning the preferences of the child, we're able to kind of figure that out. We've adapted this to art as well. What kind of feedback should kids get in terms of getting them to draw or to paint and so on. Again, chatbots can be tailored with the same tool, right? So on WhatsApp, we can essentially the manner in which the language and the manner in which the chatbot interacts with you is now also tailored to kind of get you to engage more. So that's kind of a big picture overview of the kind of stuff that I work on, mostly on using data around individuals, learning kind of what engages them, and then building out these tiny little AI models that can generate policies that are tailored towards this. So that's my story.
Hey everyone, thank you so much for joining us today. I'm excited to present work on which economic tasks are performed with AI, evidence from millions of Claude conversations. This is joint work with many folks across Anthropic, especially folks in our societal impacts team, and most especially my co-lead, Kunal Honda, for the work. This is all part of a broader effort at Anthropic, where we are putting forth this Anthropic Economic Index. And the goal here is really to provide meaningful, substantive data that we can provide reports on to the research community, and then also provide data sets, so open source data sets that basically map out how Claude models are being used across the economy for people to use for their own research. So what we see when we are looking out at the public is that AI is already having an effect on the economy. We're seeing this in the adoption across industries. We're seeing this in reports of increased productivity. And we're seeing it in at least self-reported ways in which people are making decisions. Personally, I expect this impact to only increase over time. The models are getting better, new products are being developed, and diffusion is sort of not stopping. But what's really missing is data. Because if you ask 10 different people, you're going to get 11 different opinions on what the impact of AI is going to be and what the path is that we need to take given that information. So past work here has really tried to estimate what the impact of AI is going to be across different fields. And it does that by looking at things like the overlap of skills that AI does, that AI is able to perform, and the overlap of skills that people have. But what we realize is that now that language models are broadly deployed across many different parts of the economy, and many of those run through our systems, we're actually able to look and open that up in a privacy-preserving way to provide real meaningful data about that question. So what we're going to do here is we're going to do three things. We're going to look at map Claude AI conversations to tasks in the US Department of Labor's ONET database using a privacy-preserving methodology that we developed. We're going to look at which occupations have tasks with the highest amount of usage. And then we're going to look at other statistics like deeper analysis about how AI is being used, not just where it's being used. So we can start with this ONET database, which is really this database of 17,000 different discrete tasks across thousands of different occupations. Occupations like data scientists with tasks like analyzing and processing data, creating graphs, applying sampling techniques, but also things like anesthesiologists and college history teachers. And what we can do is actually use AI to understand and map individual conversations without looking at them to one of these 17,000 different tasks. So for here, for example, can you take this data set and make a nice stacked bar chart for me? Imagine this is a conversation. The language model could read that and map it onto the most appropriate task out of those 17,000 different categories. And then once we have that, we can then bubble that up and we can look and see for which occupations do we see most of their tasks popping up in our data. And when we do that, that lets us basically map between the US economy and the number of different jobs that exist in the US economy for different categories, and compare that to the Claude economy. And what this lets us do is see a couple of really interesting trends. First, we can see that jobs that are really, really large in the US economy often require lots of real-world presence and relationships. So we can see things like transportation and material moving, sales, office and administrative support, food preparation and serving related. We see relatively little usage of Claude because Claude can't quite yet prepare your food for you. By contrast, software engineering, which has people who are disproportionately likely to adopt new technologies in areas which have low regulatory barriers to adopting those technologies, and where the models have really strong performance gains, are seeing massive adoption in our data set compared to the baseline statistics. But we're also seeing other areas that are overrepresented, including media, entertainment, and writing. So copywriters, translators, et cetera, we're seeing much larger usage in tasks associated with those occupations. And then also the natural and social sciences. So in whether this is energy research, biology research, medical research, we're seeing higher usage in those relative to the baseline. Here's another view on that data with a little bit more color. So you can see these top-level occupational categories, and then you can see specific top occupations and tasks within each. I'll go through these kind of briefly. For computer and mathematical occupations, we see computer programmers, software developers, developing and maintaining applications, debugging, maintaining databases are some of the associated tasks we see. For arts and media, we see tasks relating to managing communications, to developing marketing strategies, and those are associated with occupations like editors and copywriters and technical folks. And then in educational use cases, we see things like managing book and documentation publishing, designing and developing educational curricula and materials, which map onto tasks associated with tutors, archivists, instructional designers. All right, so this is a bit about where we're seeing usage, but we also want to know jobs are composed of many different tasks, right? And how many of those tasks across different occupations is AI actually performing, right? If you have 12 different tasks and you're using it for one of them, that's a very different story than if AI is currently being used and seeing traction in all 12 of those different tasks. And so what this plot shows is basically a curve where you can see that 36% of occupations show usage in at least a quarter of their associated tasks. 11% see usage in about 50% of their associated tasks, and 4% see usage across 75% of tasks. So you have a long way to go before AI will be used, has the potential to be used across the full swath of tasks in the economy. But these numbers were a bit higher than I was expecting, and actually, the fact is we're seeing usage across a broad range of different potential tasks in occupations. All right, I'll dive into a little bit more detail on some of these findings to get some more color. This is a graph of wage and mapping all those occupations that we saw before into, on the left, things like shampooers and food preparators who are on the lower end of the wage spectrum, to where we see the most usage in the middle on things like software development, copywriters, bioinformatics technicians, and then all the way on the right, the highest wage usage, we again see lower usage in things like obstetricians and gynecologists, anesthesiologists. So what do we see here? Again, this pattern of both things that require lots of in-person feedback, right? In-person, the AI can't shampoo people's hair, it can't serve them food, but also hints of regulatory barriers and ways in which certain organizations, which are maybe a bit more conservative at adopting technology, where it takes a little bit longer for it to diffuse, for example, in healthcare use cases, even though the models are performing quite strongly in evaluations of medical knowledge, we're not quite seeing that diffusion yet. And then this is sort of a graph that is not just about where is AI being used in the economy or for what different tasks, but how is it being used? Is it being used in ways that we term more augmentative, right? Is it being used to check people's work? Is it being used to iterate back and forth? Can you adjust this a little bit? Can you add this feature? Can you remove this feature? Is it being used for learning, to gain new skills, to be able to perform your work better? Those are in the augmentation category. And then we also see some usage in the automation category. Write this for me, do this for me, not much substantive follow-up, or maybe the only substantive follow-up is providing errors you're getting in your code and say, debug this, here's the error I'm getting, debug this. Those are the directive and feedback loop categories. So overall, we see that usage on Cloud AI tilts more towards the augmentative category, although we're going to be watching that metric to see if it changes over time. And then just, it wasn't today, but 2 weeks ago we released a follow-up report where we basically reran all of these analyses after the launch of Claude 3.7 Sonnet, which is our most recent model, which sees a number of different gains in agentic coding capabilities. And we released a whole bunch of different types of data here too. So we released automation and augmentation on a task level basis, which lets us look at the top occupations that see the most back and forth interaction with Claude, including copywriters, editors, et cetera. We also look at the use of reasoning, our new extended thinking mode, and seeing what occupations see the most usage there. It's a lot of technical tasks, as those who are familiar with the technology might have guessed. And then we also release a bottom-up taxonomy of use cases, not mapped onto ONET, which is a list of occupations as they exist today and tasks as they exist today, but a bottom-up taxonomy that creates, potentially has the potential to identify new types of tasks that are emerging. So we're seeing, people create physics-based simulations with interactive visualization components, right? And also things like help me create and improve job materials. So really trying to flesh out this picture a little bit better and give people a better eye into what's happening with the technology, where is it going, and releasing all this data open source. There's a lot of limitations. I'm happy to talk more about this in the Q&A. Our data sample is limited. We're just one provider. We really want this to be a bigger discussion, and it won't be until all of the major providers share similar types of data that we'll really have a comprehensive picture at this granular level about what's happening in the economy with models. We don't capture whether someone is using AI for a very, very basic entry-level question or a question that only a person who's been in the industry for a very long time or who has an advanced degree can capture. We use the ONET database, although we're starting to give other types of frameworks in order to complement that, as I just mentioned. And I think, very importantly, we only see what's happening within the narrow constraint of the chat interface. We don't see whether the models are really leading to, when I take my report that I generated with Claude and I show it to my boss, are they like, this is amazing? Or are they like, don't show me this ever again, right? We see people coming back, which is a potential indication that they're seeing value, but there's a lot of questions about how people actually incorporate Claude's outputs into their work. As I mentioned, all of this data is available open source. You can follow this link or go to the Anthropic Economic Index website. We're going to be updating this over time, longitudinal analyses, looking at the cadence and really tracking it, because hopefully we can get those 11 opinions down to 10 to maybe a little bit less. And we just would love to see a broader discussion across the field. It's not something that just academia, industry, civil society, policymakers can do. We really need all of our different methods, all of our different perspectives in order to understand not just what the effects are now or in the future, but what we should do about it. So thanks so much.
Good evening, everybody. I'm your closing act before our panel. What I thought I would do, my name is Samir Mayekar, I lead the Polsky Center here on campus. Since I have so many university stakeholders here, I thought I would tell you, what do we do? So we are the startup engine of the university, and our job is really to help bring new ideas and technology from the UChicago ecosystem to market. We do that in a few ways. We help patent everything at the university and manage that IP portfolio. Right now we see around 200 new inventions on campus a year. We do all of the education and entrepreneurship on campus. That includes running things like the New Venture Challenge. For those of you students out there who have promising startup ideas, you can participate in these business plan competitions. We have a venture support and funding group. We're actually launching a venture fund next month to directly invest in faculty and student companies. So expect to hear more from us on that. And then we run a small business center on 53rd Street serving 1,000 community entrepreneurs. And I'm going to talk about that in a minute. So over the course of our 20+ year history, we still have around 650 companies operating today that we've supported. They've raised or mobilized about $11 billion. Just in the past 12 months, we've had our startups raise around $800 million, and we had one very awesome exit. I'll say it was a crispy exit, if you know Simple Mills, a gluten-free cracker company. They just got acquired for $1 billion. So for the people who invested in the NVC, that was an 85x. So that was good. Maybe Anthropic's going to be more. I don't know. We'll see. But what I wanted to talk about today is just a focus on three areas. AI's economic potential, some of the downsides, and I think the role of public policy, having been in federal and local government myself. We know that this is no longer a distant frontier, and we do see AI reshaping business, labor markets, innovation ecosystems. I think the previous speakers highlighted some of that. So I'll just show a little bit of economic data here, but generative AI could contribute between 2.6 trillion and 4.4 trillion annually to the global economy. It will have major impacts in industries from customer service, software development, marketing, R&D. I think my friend from Anthropic showed a little bit of this. What's interesting to me about the sector is actually the faster adoption cycles. Each new generation of technology has faster and faster adoption curves. And so, maybe we'll see this in Anders' next presentation of where you actually see a productivity impact from the technology, but people are forecasting right now that it's going to be much faster than previous industrial revolutions. When you think about that productivity impact just on a quantified basis, AI could drive about a 7% increase in global GDP, and widespread adoption could contribute around 1.5 to 3% growth in annual productivity over a 10-year period. So I know we need to actually see this in the data, but that's what's being forecasted. The other thing I'd say that I find interesting is that CEOs, when you poll them, are seeing very tangible impacts from Gen AI. So over 50% report productivity gains, 1/3 saw profitability and revenue increases. And I think from a startup perspective, that's why the AI revolution is so interesting, because people are actually monetizing it today. And I'm going to tell you about one of those case studies here in a minute. For developing nations, also, AI offers a chance to leapfrog traditional industrialization pathways. We saw this with mobile phones. If you think about banking in developing countries that went straight to mobile, you could see that happening with AI in terms of unlocking new use cases. And something I find amazing is what's happening with infrastructure. So these are just recent announcements from Google and Microsoft. But we're talking about $150 billion a year of infrastructure investment just from those two companies. And I don't know if some of you saw this interesting story in the Wall Street Journal recently. All these data centers are being built in places with cheap energy. And they're kind of distorting local economies, and if you're a public policy maker, doing interesting things to your tax base. So in the Pacific Northwest, there's very cheap hydropower. And right now, that's where a lot of data centers are being built. So you have a surge in construction jobs. You have to provide housing for those people. Then the jobs leave because data centers don't employ that many people. But then you have this structural increase in the tax base. So you have cities now in the Pacific Northwest that are below the poverty line by a significant proportion, and they have schools, nicer than the Rubenstein Forum. And that's a huge challenge if you're a policymaker as to how do you deploy that capital. Venture capital markets are being heavily impacted right now as well. So if you just look in the US right now, almost, I think now it's over 50% of VC dollars are going to AI companies. In our NVC, 80% of the NVC companies are incorporating AI. This is a huge shift. And you know, some people are saying, are we in a 2000-like bubble? I don't think so, but these are significant figures. Also, when you just look at the total absolute amount of capital deployed, over 100 billion of VC dollars into the sector last year, that is pretty tremendous. Okay, so that's kind of the rosy side of the equation. On the more bearish side, the second big theme here is what is the potential for disruption, especially in labor markets. You know, this can just quantify the fact that nearly 40% of global employment is exposed to AI. And historically, automation and IT improvements, they've affected routine tasks. But I think what the previous speakers highlighted is that actually AI can impact high-skill labor. And that's what's unique about it. And in advanced economies, about 60% of jobs might be impacted by AI, and that number will be lower in emerging economies. And so there's one forecast that says by about 2030, 30% of hours worked in the US could be automated. And that, you know, is a significant figure to think about if you're a public policymaker. So the way in which we kind of failed to adapt to the free trade regime and NAFTA and are paying the consequences in many ways today, you know, what do we need to do as policymakers as we think about the AI transition? And that's why I would say the role of public policy has never been more critical. What are some of the areas I find interesting? I mean, number one, we have to invest in human capital in a different way. What does strategic workforce planning look like as you forecast talent needs if you're a government or if you're a company? If you're a public policymaker, how are you thinking about apprenticeship programs, about upskilling, about deploying the money you have in some of those training programs? Secondly, how can we foster inclusive AI innovation hubs? AI isn't exactly a tool that's very inclusive today. And one of the things that excites me is if you think about the work we do at the Polsky Exchange on 53rd Street, there's a huge demand right now for small businesses to be able to get the same tools that big companies have. And AI can allow you to do that. You think of inventory management, financial forecasting, building a new website, coming up with the slick presentation deck. These are now tools that can be affordable to you if you're a 5-person business. And I think the more we make those tools available to small businesses, the better. But we have to do that purposefully. The third area that I'm interested in is social safety nets. You know, the entire structure here, at least in the US, of safety nets, think about wage insurance, retraining stipends, portable benefits. What does that look like for people impacted by increased automation in the workforce? In Chicago, we deployed, when I was in government, one of the largest UBI pilots. Well, how could you think about that in the context of workers being impacted by AI? And then finally, flexible governance. You know, as AI evolves rapidly, and it's probably one of the most rapidly evolving tech sectors I've ever seen, policy has to stay agile. And if you watch Congress, you know, do you think they understand this? And do you think they're agile? Well, no. Now take that to a municipal level. If you're in a state government, a county government, a city government, how are you going to adapt to that? The tools you have are less sophisticated than those you have at the federal government level. So what are you going to do? And I think that's a humongous challenge for this country and for policymakers, is to stay kind of even maintaining a pace with where technology deployment's going here with regulation, not be 2 or 3 or 4 or 10 cycles behind. So those are some of the areas of public policy I have been thinking about. And what I wanted to close with is a story of what's happening here on campus. So we were very fortunate to have a very bright new faculty member here named Se Zhang. In addition to being a professor of computer science here, in 2023, he co-founded a company called Together AI. And that company helps simplify enterprise use of open source large language models. 50% of their team right now is dedicated to research. They have some amazing faculty members from across the country as their co-founders. Their customers are Zoom, Salesforce. Their strategic partners are Meta, NVIDIA. And in the past 18 months, they've raised $550 million. They are valued at over $3 billion, and they're the fastest company in history to get to $100 million of annual recurring revenue. And so we have that kind of talent here at the university that all of us can tap into. And here at the Polsky Center, we want to be building, 10 of these over the next decade. And it's very exciting to me to see this new generation of faculty and what they're doing. So with that, I will turn things back over to Carolyn. I think we can have a panel discussion. Thank you.
What a great conversation. I think we could go so many directions. I want to try to touch on a few things that really try to thread together the conversation we just had before I open it up to the room. So I want to pick up on this theme of how AI is used. So Alex, at Anthropic, you found that AI is more often used to augment work than automate it. And Sanjog, you also show that combining human expertise with AI leads to better outcomes. So how should we think about balancing augmentation and automation when deploying AI?
Go ahead.
Yeah, I think it's one thing that's been really striking to me is to understand the texture of work, basically. That really, when people perform a job, they're sort of weaving together all of these different tasks in different and nuanced ways in order to accomplish some sort of outcome. And to really understand what the impact of AI on that job, you need to understand the way in which it can make someone slightly more efficient in one area, the way it can improve their agency in another. And so I think the 5 different categories that we put out, which was looking at validation, people using it for learning, people using it for task iteration, and then 2 different types of more automative work, are just a start as a way to characterize that. I think really what I look for when I'm talking to someone is, do I feel like it's improving people's agency, right? Do I feel like they are more able to do the things that they want to do in their work when they're using AI, that they're feeling like they're more productive, they have more control over the work, the type of work that they're doing? Does it enable people to do different types of work that they weren't doing before? Very similar to some of the discussion we were having that Anders brought up. And so those are some of the metrics that I'm really looking for, the sort of more softer qualitative metrics that'll complement, I think, a lot of the quantitative metrics that we're seeing and how people are using it in the data.
Just to follow up on that, like taking it down to kind of a specific case study. So we ran this giant experiment where we tested out 3 different things. One, human copywriters who created ads. These are ad agency copywriters. They created ads, and you had GPT create ads just by itself without any prompting. And then we had a proposed model where we combined some A/B test results from the field with the language model, fine-tuned it, and asked it to generate models that had theoretical guarantees about performance in the field. The striking thing was, the first part was that GPT and the ad agencies were awash, right? So I don't know why you're paying for ad agencies, but it's a whole other question. But when you combined kind of the data piece, fine-tuned, you got a significant bump. The interesting part to kind of follow up on what Alex was saying was where you got that bump. So it wasn't that humans were bad at creating ads, right? So in those type of tasks where it was easy enough to create good ads, humans and the AI were similar. But when the tasks became more difficult, that's when kind of humans fell back in the AI. There was weird complementarity that there are certain types of tasks where AI can kind of help augment kind of human ability when things are more sophisticated, more complicated, that takes a little bit more of processing power that then you actually have. But there's going to be a bunch of tasks where it's a wash, if you will. So I think you'll see more of this complementarity part coming up rather than the substitution of what you're calling automation.
And I'll just add briefly onto that. There's a lot of work in economics that talks about how when new technologies come into play, they're sort of slotted in place of an old technology, or just sort of plopped in wherever people can see a good location. So for example, engines, getting put where water mills were, being used in factories. And then over time, people figured out that, oh, actually, like we could have one at each workstation. We could actually like not just treat this as a electric version of an engine that we had before, but actually like figure out a new way to use it. And I anticipate that like AI will be used very much in that way. That we see the obvious use cases now, but over time, we'll find new ways of integrating it into work that are much more seamless.
Yeah, I just want to add to the automation. I think augmentation has this positive connotation, and automation has this potentially a little bit of a negative connotation. I don't think that's quite accurate. I think the two things that are important in this discussion is, first, what are the tasks that are actually where I, as a human, is providing a lot of value added? And what are the tasks that I actually enjoy doing? And the task where I'm not providing a lot of value added and I don't enjoy doing, automation is great. Like one example for me is there's some computer programming that goes into being an economic researcher. I'm not a good programmer. I don't enjoy it that much. So having Claude help me debug my code, that's great. And it's automation. It's pure automation. It frees up time for me to think about like labor econ or something like that is closer to my comparative advantage. So I think those are the two things that one should keep in mind: value added and what do I actually enjoy doing. Yeah.
Great, that's terrific. What do you think that the effective AI human collaboration could look like as we look ahead? To anyone?
I can try again. But
yeah.
I think especially with like the large language models, they have a huge potential to bridge skills gaps, like allow people to do something that before they were not able to do. So this could be, for example, like you're signing a very complicated and long contract. You can feed it into Claude or ChatGPT and help you kind of dissect what are the legal implications of this long contract. Something that is just like would seem otherwise out of reach. You would need some very expensive legal advice. Or me starting to programming in a language that otherwise like I would need to go back to like take a computer science class or something like that. Like now I can kind of get started doing things that otherwise I would not be able to. And I think that's really where the magic potentially lies in these tools, is allow people to do something they have not been able to do before. So there's a very famous MIT economist, David Autor. He actually thinks that this can help rebuild middle-class jobs because it can allow people with like less expertise, if you will, do something that is actually creating a lot of value added.
Yeah, it's helpful. And I think that adds some color to the concerns about automation and the labor market impacts of automation and the fear that this will take over the jobs. And so I think there's some optimism. There are some things to be optimistic about.
Carolyn, can I?
Yeah.
So human AI interaction, let me tell you the good story and the bad story.
Great.
So in the good story, we, via our new fund, invested in a company called SimCare AI. It's some UChicago students who are now in Y Combinator, and their product helps train clinicians. And so it's like a kind of like a enhanced chat bot that can help train a clinician and kind of reduce their certification time. So that's a really interesting use case of human AI interaction. I was recently with someone at Duolingo, and they're saying that learning other languages, there's some super interesting use cases there. Okay, so what's the dark side of that? There's a company called Character AI. Who has this downloaded? Does anybody? Okay, a couple people do. So this allows essentially mainly young people to have a chat interaction with their favorite like Pokemon character. Okay, and in some ways that can be used to like work up the courage to have a conversation, to train yourself about having a difficult conversation. But what also is happening is that young people are spending hours talking to Pikachu instead of with their friends. And the kind of addiction is there. And that's a very kind of problematic human AI interface that I worry about, given what we read about isolation and what that does to society. So I've seen both the positive and negative, and I think we're in the early innings still on that.
Yeah, thanks. So I want to go a different direction and think a little bit more about the labor market. Anders, your findings that you shared from today indicate that the productivity gains from chatbots and other other AI tools aren't necessarily there. Can you break down why you think that is?
I think and it's natural that we want to start off with showcasing where it has the greatest potential. And a lot of the very early experiments had the flavor of, if you had just copy-pasted in from ChatGPT, you would have aced the assignment. But most things in life are not like that. And that's, I think, one key reason is that most tasks and most jobs are not just something you can copy-paste from ChatGPT. Mm-hmm. And then I think the second thing is that a lot of these experiments, they're done in a very controlled setting where workers have the optimal conditions to really benefit from the tools. And most workplaces are not like that. Most employers don't even know who of their employees are using the tools. So how should they be able to support them in using it? So I think before, and I'm sure this will happen, like in some years, it will just take some time for firms to really reorganize the way that they work to really harness the potential of these tools. But before we've seen these workplace transformations, I don't think we should see these productivity predictions really to play out in the real economy.
Just quick follow-up.
Yeah.
I think there's a flip side to that we're just listening to you speak, right? So I'll give you an example. This NGO that I'm working with in a small NGO in India, right? So their task was the one I talked about, where kids basically are given art assignments. They draw something, it comes up. And initially what they had was they wanted to give feedback to these kids to encourage them and so on. So a human would look at the piece of art, kind of design some feedback, type it in the chatbot, it would go out there. They quickly realized that can't scale. So what we did was we built out like an AI that could do this. But in some sense, that's kind of disguised automation, in the sense that if you wanted to scale this and you would have to hire more people. And so you wouldn't see this because it isn't actually replacing jobs, but it potentially could happen. I think there's a lot of these tasks that we'll see where it's not like there was a human in play and now it got replaced by the AI, but AI will do the job of something or someone that we just have, it'll be disguised in some sense.
I have another why, Sanjog, for you as we think about public policy adoption. And when you showed us the SNAP study and you end with, if everyone took this up, look how much more food assistance would be distributed and how great that would be. And you talked about how, well, it hasn't been taken up, and we chuckled. And we understood, right, that the money for that intervention is not just sitting somewhere. And we also understand the political context right now, but this was before that. And so how do you grapple with findings that can be so impactful and then don't necessarily get taken up? How do you make sense of that? How do you make sense of that? Because we're here talking, and for you personally, and then for others, as you're developing so many insights, we're thinking about public policy. What is that uptake like?
No, it's tough, right? So even so, like SNAP is this weird thing to be, just so you know, it's administered at the county level, not even at the state level or the federal level. And so you have to deal with each individual county, and you're right, there's financial issues, there's politics, and so on. But the other thing that's kind of is interesting is, I think this came up both in Andrew's talk and Alex's talk, is that and actually even Samir's talk, the infrastructure doesn't exist, right? So if you look at kind of across, like when you're working with San Francisco County or LA County, like then that's easy. They have the resources, they're big enough, they have scale, they have the technology to kind of do all of the stuff you want them to do. But if you start going to valley counties, if you will, or in California, they just don't have the resources. So I think one of the things with AI that we might see happening is exactly this point that came up, which is it's going to lower the costs of technological interventions, if you will. You'd be able to scale this. And you're seeing this in developing countries. Like in India, pretty much everybody has WhatsApp. And WhatsApp has an AI built into it, so which means everybody has access to AI. but you also have an algorithmic way of interacting with people at scale. And so you can feed in Claude or OpenAI into WhatsApp and then intervene in a very natural way. And I think that's going to happen other places too. So the government of India is making these big investments in being able to take AI to disseminate information about programs. It's not just in India, it's happening across the board in the Middle East and Africa and so on. So I think there's going to be, I'm positive about where things are going. I think partly it has to do with just not having the knowledge, not having the skill sets, not having the technology, and those costs are coming down dramatically. So.
What about subjectivity of outputs? How does that impact policy?
So this is connected to this other piece of research I have, which is like anything that you generate out of a language model by definition is subjective in the sense that you design the prompt and you don't stop changing or tweaking or engineering the prompt until you get to a point where you like the results you see. So whatever you generate is by construction subjective. Now, why is this important? Kind of just looking up, think about what's happening moving forward. Like Anthropic's put out this thing called the MCP protocol, and agentic AI is kind of, if you haven't heard of agentic, you will in the next year, right? And so you're going to have these agents that we think are going to be these objective agents that act on your behalf to maybe negotiate prices or to do a bunch of tasks. But there's somebody designing and prompting those agents to do stuff. And in a small experiment that I ran, like you can get like this massive heterogeneity of these agents. So just like you have, variation in abilities of humans, you're going to get variation in abilities of these agents. Some are going to have more access to tools, some are going to have less, some are going to be better at doing some things and some are less, and they'll charge you more and charge you less. So I think that the next version of the economy is going to be interestingly complicated.
Yeah. Well, I think we can agree on that. Alex, you've looked at how AI is deployed across different industries and different populations. What were some of the most interesting and surprising findings there?
Yeah, I think one thing that I noticed both anecdotally and also in the data was the tremendous concentration of usage in coding. And I think that lines up with a few cases, a few factors. One is, coders are disproportionately more likely to adopt new technology. Also, the models are really, really good at code. And there's not that many regulatory barriers to just sort of like taking it up. By contrast, you look at things that AI can't, even do across like the service sector or across, much more highly regulated, much more conservative industries like hospitals, and you see sort of much, much smaller dispersion of AI at the moment. It's slower, I think it's going, but I think looking at across those different factors is a good way of understanding, why you can have, people posting on Twitter that they, built an app that would have taken them, $100,000 and 10 people in 12 months, that they could have done it in like 10 minutes and $10, with new agentic coding products. While you can have that world, one of sort of intense productivity gains in a sort of, small bottle, and yet contrast it with, perhaps like the normal economy, things like Anders's work where you see much less of an impact, right? And over time, I think what you're going to see is the models are going to get better. I think they're continuously improving and becoming more capable. People are then figuring out better products to build around those models that'll make them easier to use, more intuitive. You'll sort of not have to figure out where that box is and type it in. It'll sort of anticipate. The costs are going to go down too. And so I think you're going to start to see that diffusion across that gradient a lot more. But that's some of the differences we've seen.
Do you want to weigh in on the labor market impact as well?
I think the most surprising finding was probably the gender gap for me.
Yeah.
I had not at all anticipated that. And that turned out just to be the key finding of the first paper, is just that women are much less likely to have taken up these tools. And this is really comparing two workers that are working in the same legal firm, handling the same legal tasks. The female paralegal is more than 10 percentage points less likely to have adopted the tools. That was just like a complete shocker for us.
Do you know if that's consistent with other adoption of other technologies? Is there a gender gap there as well? You might not know.
We know that men are over dominated in STEM fields, but I think the shocking finding is that it's within very narrow job categories. I had not anticipated that at all. I want to say the second surprising finding is that despite the fact that these tools have this potential to bridge skills gaps and really help lift workers with less expertise, that I said, if you look at who's actually using it, it's workers who earned more already before ChatGPT was invented. So if you look at actual use pattern, it just reinforces existing inequalities. So I think that's also something to keep in mind, is that there's this potential to build the middle class. But if we don't do anything and like help the lower achieving workers, or you will, or just workers who have less expertise already, they might not get on the train. So that's at least also something where I was surprised.
Samir, you spoke in your remarks about the work that the Polsky Center is doing on economic inclusion related to the Polsky Exchange. What else can universities do to help expand adoption and expand more inclusive adoption of these tools?
So two examples I'll give, something we're doing right now, actually. So we're feeding all of our kind of research paper and invention disclosure data into a model, and then figuring out what is highly cited by a lot of patents and other researchers. And this work is showing that there's kind of pockets of places in this campus where people should be patenting things or starting companies. And what's interesting is this also showed a gender gap. That there was a huge kind of difference, and this was done at Northwestern, actually, where in the work they did, they found that more women had highly cited papers that could be patents, and they weren't filing the patents, and they filed the patent, and they have a couple of startups now that came out of it. So really interesting work, and so we're adopting that here, and it's all done by LLMs. So that's one example. I think the second is at the Polsky Exchange, we're bringing in really smart people from industry to do training sessions with small businesses. I think that is key. When you hear AI, it seems so challenging at first, and it's kind of hard to understand what it means for your small business. So the more we can get industry players there offering kind of that technical assistance, that is a huge area where we're just trying to connect with industry to do that for our small businesses.
Great. Well, thank you. Thank you so much to our panelists. What great discussion. And thank you all for joining us tonight.